Okay, so we are going to start stage 2 of this fight. So the opponent challenged the reporter for the problem. You have 1 minute.
We would like to challenge problem 15. Let's go.
Accept. So problem number 15. Please, each member of the team please write your name on the board.
Reviewer, you have to sign out. Review.
reporter takes the floor.
Hello everyone, my name is Chen Yang from Insulator, and today I'm going to report the problem number 15, water risky. And here is my problem statement. Gently place a piece of tracing paper on the surface of water. It rapidly grows into a scroll and then slowly uncurls. In our experiment, we will explain and investigate this phenomenon. So in this experiment, we mainly focus on the following 2 points. The first one is the process of the tracing paper curling, and the number 2 is how the relevant parameters affect the experimental result. So here is our experiment video. You can see that when the tracing paper is put on the water, and it will curl into a scroll, and then after a while, it will return to flat. And I found that the speed of the curling will be slower than the curling. So here I'll introduce the tracing paper curling process to you. This is a side view of the process, and this is a top view of the process. So you can see that at first the tracing paper is flat on the surface of water, and then it starts to curl, and then curl to maximum, and then uncurls and return to flat. So here is our comparison between the cold water and the hot water. So in the cold water one, you can see that the hot water, the speed of the curling will be much more faster than the cold water. So here comes a conclusion that the water absorption of the tracing paper is because of the diffusion, not because of the capillary action. Because in diffusion, we all know that the higher heat will cause faster decrease. And this is our Timoshenko's work by metallic thermoset. So we suppose the tracing paper is a 2-layer construction. And in the picture, you can see that the water gradually penetrates the lower layer, and then the higher layer. So we can know that the water content gradient causes the tracing paper to curl. And then I'll introduce more detailedly in this page. So with the hypothesis above, we can assume that the higher layer is the layer 1 and it's dry, and the layer 2 is the lower layer. So we all know that the natural lengths of the dry, wet, and foley weights are different. So when the tracing paper absorbs water, the layer 2 will become wet. And the L1 here is the natural length of the layer 1, and the L2 here means the natural length of the layer 2. So after it absorbs the water, we can know that L1 will be bigger than L1, which means that it is stretched by the layer 2. So the layer 2 will be smaller than the L2, which means that it is shortened by the layer 1. And we know that the layer 1 will give the layer 2 a compressive stress, and the layer 2 will give the layer 1 tensile stress. So here and now I'm going to introduce the 2 explanations for the relationship between the curl direction and the fiber orientation. And here, this is the first explanation, which is the Young's modulus calculation. So this is how we calculate it. And in the 2 graphs, we can know that if we want to strengthen, if we want to lengthen the side parallel to the fiber orientations, the Young's modulus is bigger than the side vertical to the fiber orientation. So we know, so we can know that if the tracing paper wants to curl wants to curl this one like this, the force will need to be bigger than curl like this. So of course the tracing paper will curl like this. And this is the second explanation for this. So we measure the expansion of the 2 sides of the tracing paper, and in this graph we can know that the side vertical to the fiber orientation is bigger than the side parallel to the fiber orientation in every pass. So we can know that the curl direction will be perpendicular to the fiber orientation. And in the experiment, I have observed that it has 3 different conditions of the curl. The first one is that the 2 sides didn't touch together, and the second one is it's just only a 1 circle, and the third one is the 2 circles. And this is the limitation. So here is our experiment setup. we use the robot to put the tracing paper on the surface water because we think that if we use hands to put it, it is not accurate enough. So we use the robot. And the process of it is that if I press the button on it, and the robotic arm will go open, and the tracing paper will fall onto the water. And this is our experiment data for the curvature. So our manipulated variables are the aspect ratio and the poundage of the tracing paper. So the aspect ratio means that we fix the length of the side vertical to the fiber orientation and change the side parallel to the fiber orientation. And our control variables are the distance from the robotic arm and the surface of water is 1 centimeter, and the temperature and the humidity. So in the graph, you can see that when the length of the side parallel to the fiber orientation increase, the curvature will also increase. And when the poundage of the tracing paper increase, the curvature will decrease. And this is the analysis of the time. So it is the graph on the left is the time to curl to maximum, and in the graph you can see that different aspect ratio will influence a lot of the time to curl to maximum. But if the poundage of the tracing paper increase, the time to curl to maximum will decrease. And the right one is the time to return to flat. So in the graph you can see that when the length of the side increase, the time to return to the flat will also increase. And when the poundage of the tracing paper increase, the time to return to flat will also increase. And now I'm going to change the fiber orientation of it. And we control the length of the side parallel to the fiber orientation to 1 centimeter, and we change the length here. So in the graph you can see that when the length of the side vertical to the fiber orientation increase, the curvature will also increase. And when the poundage of the tracing paper increase, the curvature will decrease. And this is the analysis of the time. So in this graph, you can see that different aspect ratio will influence the time to curl to maximum. And when the poundage of the tracing paper increase, the time to curl to maximum will also increase. And the right part is the time to return to flat. So in this graph, you can see that the length of the side increase, the time to return to flat will also increase. And when the poundage of the tracing paper increase, the time to return to flat will also increase. And the third experiment we do is that we control the aspect ratio of the tracing paper but different area. So we do this manipulated variables, and this is our result. So in the graph, you can see that the area will influence a lot to the curvature. And this also the time analysis. So in the graph, you can see that the different aspect ratio will influence the time to curl to maximum. And in the right part, you can see that when the length of the side increase, the time to return to flat will also increase. And this is our discussion for the rolling velocity. So in the graph, we can see that the time of curling process is shorter than the uncurling process. My explanation for it is that at first the tracing paper is all put on the surface of water. So, but after it starts to curl, some parts of it won't touch the water. So the speed of the water absorption will be slower. So I think that's why the time of the curling process will be shorter than the uncurling process. And the second point I want to discuss is that when the poundage decreases, the curling speed will decrease. My opinion for that is that the poundage, if the poundage decreases, the thickness of the tracing paper will decrease. So it will need more force to bend it. So that is why when the poundage decreases, the curling speed will decrease. And here comes my conclusion. So there are my two main focus in this experiment. The first one is the tracing paper curling process. So how does it process? The water diffusion acts on the tracing paper, then the natural length of the upper and the lower layer become different. And the upper layer gives lower layer compressive stress, and the lower layer gives the upper layer tensile stress. So it will curl. And after a while, the natural length of the upper and lower layer gradually become the same, so it will return to flat. And this part is the relevant parameter to affect the curl. So the first point is that the different expansion of the two sides will cause the curl direction. Will cause the different curl direction. So so we can get that the curl direction will always be perpendicular to the fiber orientation. And this part is that when the length of the side parallel and vertical to the fiber increase, the curvature will also increase. And when the poundage of the tracing paper increase, the curvature will decrease. And some aspect ratio, at the same aspect ratio, but different area will influence the curvature. And this part is of the time. So different aspect ratio will influence the time to curl to maximum. But if the poundage of the tracing paper increase, the time to curl to maximum will also increase. And when the length of the side increase, the time to return to flat will also increase. And that's all my presentation. Thank you for attention.
Okay, now for test questions, 2 minutes.
Okay, so first, you mentioned the ratio between the layers of the tracing paper. So did you calculate the ratio
The ratio?
between the layers?
The layer of the item. It's just you mean the construction of the tracing paper?
Yes.
It's just a hypothesis that we explain the tracing paper curling process.
Okay, and you mentioned that the curling is perpendicular to the orientation of fiber. So how did you observe the fiber?
Okay, and in our experiments, we observed that if we want to lengthen the different side of the tracing paper, only if we lengthen the side vertical to the fiber orientation, it will appear something like line on it.
Okay, and you mentioned that you controlled the humidity. So how did you control the humidity?
So we pick the same humidity days to do the experiment.
Okay, so as the problem statement, the uncurling rate is slower. So how can you explain this?
I have mentioned in my discussion, it's because that when the tracing paper at first puts on the surface water, and then the whole paper will touch the water. So and when the tracing paper starts to curl, and like this part won't touch the water. So the condition is different. So the velocity, so the speed will.
I understand. That's it. Thank you.
Okay, so the opponent has 3 minutes to prepare. Okay, opponent takes the floor. 4 minutes.
Honorable judges and worthy debaters, this is the opponent from each opposing problem 15, wet scroll. And for the problem statement, if we gently place a tracing paper on the surface of water, it rapidly curls into a scroll and then slowly uncurls. So the reporter focused on the process of curling and discussing the relevant parameters. So here's a summary of the report. So for the phenomenon, the tracing paper starts from flat, then curl and uncurl with a slower rate, and then become flat again. And for the theory, the first one is that the temperature of water will affect the phenomenon, and it is because of water diffusion. And the second one is the simulation calls for bimetallic thermostatics, and that is because the two-layer of the model, and also the Young's modulus. And the last one is the curl direction is perpendicular to fiber orientation. And for the experiment, they conduct experiments about the curling limitation, which they use robots to make sure that the experiment is accurate. And also, they discussed the curvature and the paper's mass, also the paper's length and width ratio, and the rolling velocity. So for the pros and cons, the pros, we think that they took different kinds of curls into consideration, and that's really good. Also, they used the robot to decrease the error that would be caused by manual operation, and that's a really great way to conduct experiments. And they have strict control of variables to ensure quality of experiments. And for the cons, they draw conclusion of theory only because temperature changes with diffusions. And we think that it's too vague. And also, they talk about how temperature would affect, but they didn't have formal experiments about it. So later, we're going to discuss, for the theory, the relation between the diffusion and fiber orientation. And then another one for the theory is the different length and width will result the different curl, and we're going to discuss on this. And for the phenomenon, we're going to discuss which is the main cause of this phenomenon. And also, there are other topics we're going to discuss. First is the humidity and the fiber orientation, also the experiment on temperature. So I would like to invite the reporter. So first, you mentioned that the temperature will influence the whole phenomenon. So do you have any experimental data that can support your theory?
I say because the temperature is the control variable of our experiment. So the main focus in our experiments is just only the tracing.
So, but you mentioned that the temperature will influence the phenomenon in the beginning of your report.
Oh.
So, do you have any actual evidence?
Why I put the page is that we want to compare with the cold water and the hot water to prove that the water absorption of the tracing paper is because of the diffusion.
Okay. And so, do you acknowledge that temperature affects a lot? Is a great parameter that affects a lot.
Oh, yes.
So why didn't you take this into consideration?
Yeah, I say that this is my favorite variety.
I mean,
You
have
mean you want to take into the manipulative one? I say that our focus is to change the different aspect, the show and the area. So we learn
one is, you mentioned that water diffusion will influence the whole phenomenon. And also you mentioned that the direction of the scrolling will be perpendicular to fiber orientation. So what are the relation between diffusion and fiber orientation? Can you elaborate on this?
I don't think it has a lot relationship because why I mentioned the diffusion is because I want to say the principle of the water absorption of the casing is not.
No, I mean, why? So, water diffusion will influence the phenomenon, right?
The diffusion? No, it's just an explanation for in my experiment. I think it's not a factor to affect our experiment.
So, what actually caused the difference of the expansion? If you
Expansion?
don't take this into consideration.
You mean the extension of the two sides of the paper?
Yes.
My explanation for it is that we observe that this side, which is the vertical to the fiber orientation, will after it absorbs the water, it will get longer.
Yes. So, why will this phenomenon happen?
I think it's because that we can imagine the fiber to like a screw.
What?
We can imagine the paper and we can imagine the paper like a screw.
Okay.
And because the fiber orientation is like that, so the water will go like this.
Okay. So, since you mentioned that the expansion of two sides of the paper will influence the direction of the paper scrolls, right? So, if we try to make the side perpendicular to the fiber orientation small enough so that the expansion of the longer side of another side will be larger than it. So what will it happen?
I think if the length is short enough, and the expansion may be bigger than when the original wants the direction that the original wants to curve. So I think the direction will change, but only when it is small enough.
Okay, so that means in some condition, the direction of scrolling might be not perpendicular to the orientation of fiber. Is that correct?
Yeah, but only in some. You say that it's small enough, so that we don't talk about this in our experiments.
But you mentioned that it's always perpendicular. So do you acknowledge that you have lack of some consideration in this part?
Okay, I'll.
So maybe you can try to expand your experiments and you can get a more accurate consequence. And the next question is, I asked you how did you observe the fibers, and you said that you cut the paper and you saw some.
I'll show you this. So if we immerse the casing paper into the water and it will absorb water, and if we lengthen like this, we add force on it, then it won't have something different. But if we strengthen like this, it will have some fibers appear.
So actually, you make sure that all the fibers are in the same direction.
No, and we under the microscope. But because it is in the microscope, we can't like observe the odor of the fiber ornamentation. It will become like this odor. But because the content of the fiber here is like only a couple percent, so if we just use eyes or like the method I just mentioned, we can know the whole fibers orientation.
Okay, so maybe I think that it's better that you figure out a way to observe the fiber. Like maybe you can use microscope after the paper exam.
We have. So
And so what you
it's the same result. We can't observe it under the
but
microscope.
you mentioned that you can see some fibers by your eyes, and now
I said that we can see the fiber orientation under the microscope. That's whatever is before the water absorption or after the water absorption.
it contradicts your statement just a few seconds ago. Since you said you can't observe anything with the microscope, and you now said you can.
I said I can't.
But you can't.
Yeah.
Okay. So about the theory, how do Young's modulus explain the time of the curvature? Can you elaborate on it?
Yeah. Later, but I think the reason why we put the Young's modulus calculation here is because we want to explain the relationship between the fiber orientation and the curve action. It does not affect the curvature of it.
So the Young's modulus won't affect the curvature, right?
I think it's not the main point we want to discuss about.
And can you turn the page off? So you mentioned the length of the side vertical to the fiber orientation. Well, as the length of the side vertical to the fiber orientation be larger, and the time of expansion will be larger.
The time of the expansion is around yes.
So can you elaborate on why does this happen?
I think it's because the longer it is, the distance between the two stroke will be longer, so it will take more time to recover. And there, I think there may be.
So did you observe do you have some accurate evidence of it, or you just guessed it?
It's my opinion, and I think there is another explanation for this. Is that
Okay, time's up. So the opponent summarize the discussion 1 minute.
Okay, so during this discussion, we first focused on the temperature, and I think that the reporter failed to consider it as a manipulated variable, since they mentioned that it affects the phenomenon a lot, but they didn't consider it. And also about the diffusion, they didn't clearly explain about the relation between diffusion and the orientation of fibers. Also, they couldn't find it from the microscope of the fiber orientation. Also, about the Young's modulus, it doesn't affect curvature actually. Okay, thank you.
Okay, so reviewer asks questions, 3 minutes.
What was the big
can you remove your mask?
Do you see the difference of decrease as the system?
Yeah, I think it will, but the performance statement say that it is put on the washer, so we didn't investigate it.
Yeah, I want to ask a comment. Why do you think why is the fiber orientation related to the
Since the direction of the water diffused in the tracing paper is related to the fiber orientation, so the rate of it will be influenced by direction of it.
I want to ask, do you consider the surface tension?
I think surface tension is not the main focusing point.
I think it is actually an important parameter, and however, the reporter didn't take it into consideration.
Can you think of page 6? What's the difference between, as I know, this theory is using metal, and how can you apply this to this
I use this hypothesis is because that I want to explain why will it occur. So it's not connection.
what is the difference between the waste and falling fully waste?
Oh, it is this. The natural lens will be different.
This.
Yeah, lens. The natural lens of it will be different.
Okay, so the reviewer has 3 minutes to, 2 minutes to prepare your presentation. Okay, the reviewer takes the floor.
I want to go through it and the result from the report. And today I'm going to review 2018 first book. Here is the summary of the report for environmental. We discuss the variable of temperature, flow direction, ice, and the rest. And I use the robot to cook the paper. And they discuss about the rolling velocity and for the reticle. They use the Young's modulus, and they consider about the humidity and the temperature. And they discuss the curl limitation. And for the strong point and weak point of the reporter. For the strong point, they have a clear explanation and voice, and throughout and a clear theory model, and lots of experimental and good time management. And for this point, they didn't compare between the theoretical value and experimental result. And there are a lot of the connection between diffusion theory and particle direction. And here are the summary of the opponent for experimental. They use how to control the humidity and how to observe the direction of the fiber. And for theoretical, they use how this diffusion works and how this fiber orientation works. And for opponent, they have full confidence and they mention some important questions. For the discussion part, the opponent asks the reporter the relation between the diffusion and the fiber orientation. And the reporter responds no. And in our opinion, it seems that the fiber orientation will cause the expansion coefficient different. And then the next question is temperature influence about the reporter response is yes, indeed. However, we didn't explore experiment on it. And in our opinion, we think that temperature is influenced a lot, and it might become the future world with some theory. And for the second question, how to observe the fiber? The reporter response is immersed to the water and observe. And we agree with the opponent that some fiber direction is not the same at all the time. And for a review question, do you consider the surface tension? The reporter response is they didn't consider it. They think it has not a big effect. And the opponent response is they think they are important. And we agree with the opponent. And the next question is how they define the device of the wave and for the wave. The reporter response is the depend on that and on this. And in our opinion, as we think this is not so complex.
Okay, so the concluding remarks from the reporter. 2 minutes.
Yes, thank you for the opponent and reviewer. So now I'm going to have a concluding remark. So in the discussion time, we talk about that the fiber orientation. So at first we use the microscope to observe if the result didn't work out. So we use the way of pulling the tracing paper and observe the direction of the fiber because when we pull it, we will have a line on it just like this. And actually, we can use our eyes to observe it. Just yeah. And the second point is that at first the whole tracing paper will touch the water, but after our tracing paper will curve, and at this time, some parts of the tracing paper won't touch the water, so the speed of the curling process will be slower. And we did more parameters than the opponents say in the presentation. For example, we changed the different temperature.
No verbal communication.
And this is my conclusion for my experiment. The way we use I use the Timoshenko's for bimetallic thermostats to explain to explain why it will curl, why the tracing paper will curl. And also I use the relative expansion of the different sides of the tracing paper and the Young's modulus calculation to explain the relationship between the curl direction and the fiber orientation. And we have done many experiments like the different aspect ratio and the different area of the tracing paper to explain this phenomenon. So, here's
So time for question from juries. So any question?
So I have a question to all of you. So do you expect to see the same phenomena if you change the water to, let's say, oil?
No, we won't.
Reporter first.
I think it will change the result.
Do you explain your statement?
I think because the surface tension will be different.
I think it will.
And
Yes, sorry.
I think it was a better result because the oil might not suspension.
We won't observe the phenomenon since it's hard for the tracing paper to even absorb oil.
I want to correct my answer. I think it's because the viscosity of the water and oil will be different.
Thank you.
Okay, more questions? Okay, then time for, please. So.
Okay, I think report have many good detailed data. Okay, could you show any one of your data? For example, the time depends on the width, thickness, or something else. Okay, and okay, this one good. Okay, we know. Here you show the change of length do not very clearly change the time or curvature, that's right? Because I think the curvature is local property, right? So that maybe not change with the length. Okay. So the problem is since you see the curvature mostly change with the poundage, right? The thickness or other, yeah. But do you have a clear explanation about this result? Why the curvature change with your poundage? And also, can you show earlier data? Okay, earlier. Okay, another one. Okay.
Another one?
Yeah.
You mean
Another one. Okay, next one. Okay, here. So also you can see since the curvature should be local parameter, right? However, here you show the curvature change with length, the large scale length, and why? So please each team explain this phenomenon by your own explanation. Okay, shortly.
do you mean that the
Why the curvature here is why that change with poundage and why the curvature change with length? Because curvature should be local property, right? However, why the increase of length change the curvature?
I think it's related to my limit of it. Because if the length of here is not long enough, so maybe it just have one circle, and of course the curvature of it will be smaller because the circle is bigger.
We think that the main reason of different curvature is that the different paper. So as long as the paper is the same, and the curvature will be the same.
But the result do not show the same curvature. And the reviewer?
Okay, no verbal communication. Please use no verbal communication. Okay.
Okay?
We don't think the curvature will change by this.
Okay. Okay, thank you.
Okay, time's up. So time for scores. Okay, so the score for reporters. Yeah, for the reporter, 75898. opponent.
Yeah.
6, 5, 9, 8, 7. And the score for the reviewer, 6, 5, 6, 7, 6. Okay, so any comment from the jury for each of the team?
Should I explain the opponent? Well, actually, I think opponent, the person who provide very good point of view and to have a very good relevant discussion. So that's why I give the higher score.
Thank you.
I give a reporter a relatively low score. I think because you have great data, right? However, you do not well use this data to do more advanced process and explanation. For example, you should explain why the thickness or pump relative to the curvature. And in fact, this phenomenon should be related to the length or the gravitational force of the paper, maybe. However, you do not use data to explain this more complicated condition. And for some condition, you maybe discuss the different side property of the paper, because you have A, B, two different material in your paper, right? You think two layers by their model. Yeah. However, you only see the one version curvature of your paper. That's maybe interesting scientific phenomenon. Maybe you can have better explanation and analysis.
Okay, I will add one more comment to the reporter because since the fiber duration is so important in your theory, you might want to show some result or some kind of observation support your statement. You definitely say there's something different due to the orientation of the fiber, but you just keep it for the opponent to ask you over and over. Okay, so I think that's one point I would like to add. Any other comments? Okay, so we will conclude this